Okay, let's get it. What? Oh. I was trying Escape from Tarkov, which I have, but the single player version and its mods. No luck. The frames just tank too hard. Excuse me. Okay. Okie doke. Good? Good. Not as much time for this little run, but it'll be an hour and 18 of learning, and then the standard hour and a half of re-putting shit in the brain. It's crazy how being tested on something locks it in. Yesterday in the test section, I couldn't remember what unnamed namespaces are for. It's for implementation files, CPP files, where your definitions are. And you want some of those definitions to be invisible to the linker and just have internal linkage. But instead of making all your functions static and having to make your variables constant or something, well, how do you make a global variable have local linkage? Well, you have to put them in an unnamed namespace, yo. So, that, oh yeah, and then, what else? There was another thing too. There was, bitwise operations, I think I remember now. So we got and equals and or equals to set them. And then there's the, like, the insertion operator, or the bitwise insertion, but I don't know what it actually is called. Where we're shifting the bit over, or its value over, and then we can do a not to flip the whole thing, and then assign it and turn things on and off or flip it and whatnot. Unnamed namespace, that, and and the as if rule is that the compiler is allowed to optimize however the fuck it wants as long as it doesn't affect the program behavior. Okie doke. So now we're on to explicit casting. Did we do anything crazy here? Reinterpret. No idea about that. Okay. Okie doker. Implicit. Yes. Yep. When we wanted to promote from a narrower to a wider type, implicit is cool. Yeah. 4 fits into D, or 4 fits into 10 two times. And then this is type converted because it's going from an integer to a double. So it's numeric conversion, not numeric promotion. And it will initialize this with 2.0 because it will turn this into, it will numerically convert it into 2.0 and then initialize. Yes. Numeric conversion. Yes. Yes. Yeah, because you'd want 2.5 here probably. In the case where we're using literals, yeah, so we're doing a double and a double, 2.5, boom. Oh, I think what we're saying here is, how do we get 2.5 to be the correct result here if 10 is a variable that's an integer and 4 is a variable's value that is also an integer? I can't go and just change the type of those variables. So what do? We explicitly convert it. Well, in that case, wouldn't we have to do the division of the static cast of either one? Or at least, I guess we could static cast one of them, and then we have a common type because the numeric, or the integral value will be converted into a floating point if we already cast it. Because if we just cast the result is 2, which just converts it to 2.0, so that doesn't help. Yeah, so in this case, we're cool. But if we're using variables, we don't want to go and change it. Yes, so we'd still get 2.0. How do we tell that we want to use floating point instead of integer? Literal suffixes can't be used as variables. But yeah, we can't say like, hey, YL or YF to convert this guy. We'd have to static cast one of these. And then that one takes priority, and then boom, we're cool. Yeah, literal suffixes are only for literals, not variables. Some way to convert one or both to a floating point so that floating point is used instead. Yes, so we could do static cast. That's the one that I would do right away. So we could say why are the colors changing? Oh, some Git stuff happening. Oh. Okie dokie. Let's just say explicit casting. Okay, I don't want to see that anymore. Okie doke. So now we'll say an x is 3 and y is 4. And I want double z to be 0.75. In this case, it would be 0. Or, well, hold on. 3 divided by 4? Yeah, it would be 0. Oh, what is happening here? Oh, why am I don't know why I did that. Oh, the point is we have these guys in the double. It's not checking because it's saying that, hey, there might be a value for this integer that I think maybe we can fix this with const expression. We can, because it'll actually check to see, hey, is this within range of z? Can z hold this? Yes, it can, of course. Oops. Yeah, so it says 0, and then it just trims off the trailing 0 because it's standard character output. It's just what it does. But if we instead here did static cast to a double, then we're cool. And the reason is because this evaluates to a double. This is an integer. 2 operands of this division operator. What is the common type? Well, we have at least the same amount of memory as a floating point value, so the integer is converted. Well, I think regardless, the integer is converted to the floating point value. If it's within range, at least. So in this case, the integer now gets converted to type double, and then boom, we're cool. The double's the common type. Yep. So I need some way to get one or both, so floating point division happens. Typecasting, we have a bunch of them. Okay. Casts. And the cast is, I don't know why it's called casting. We're explicitly converting something. So there's implicit and explicit conversion. Cast it. Thinking of like a fishing line. If I'm casting it, like I'm moving something from one place to another. So if we're in like the integer country and I'm casting a guy, the value, over into the float country, now the end value is a float. So is the casting that we are... The word is just kind of weird to me. I never use cast. I never say cast. I mean, we do cast in Unreal Engine, but oh fuck, it's actually been too long since I've used Unreal. We can just cast it to whatever the fuck. Excuse me. Casts are explicit requests. It's called an explicit type conversion. Makes sense? Yes, instead of implicit. Oh, I was thinking about the compile time one, and there was something else about asserts, but that's a static assert, I think. C style cast? Interesting. The first four are called named cast. So what is a C style cast? Is that where we're like casting a C style string to be a standard string? Or vice versa? Well, I guess it would be C style because if we can't save a C style because there's no C style type, then it wouldn't be named. So we'd be casting a literal to something else. It's like I could see something cast to a standard string, the literal of C style string. Static, dynamic, constant, and reinterpret. Oh, okay, I think I was totally wrong. Alright, so compile time conversions between related types, which means that sometimes they can fail. The dynamic cast. Static cast is at compile time. Oh, so yes, a static assert is at compile time versus an assert is at runtime. Just like a static cast is at compile time as well. Gotcha. Or it'll say, hey, I see the static cast result. I see the result of this static cast of a this to a that. Boom. You're cool. You're allowed to go ahead. You may do it. You may continue. Dynamic cast are runtime conversions on pointers or references in a, I don't know why that says in an, but in a polymorphic inheritance hierarchy. Meaning, I think dynamic cast are what we're using in Unreal Engine. So if we're talking about an inheritance hierarchy, where there's this base class and then there's a class that is underneath it as a child. Mm, we might not. If it's a child, we should have access to the parent stuff. Seems like if we create a child of something, maybe it's the case that we can't automatically use the member functions from its parent class. So we have to dynamically cast it to its parent to say, hey, as long as this guy is a member of this class, he's an instance of that class, or a child of that class, we're golden. And this involves specific objects that we're referencing. Why specifically? I think references makes the most sense. I'm not super sure about the pointers here. I guess the pointers there are different types of pointers depending on what type of variable or object we're pointing to, which is weird to me. I would think that the piece of, or the object itself defines the behavior, and we just have an object pointer to point to these different guys. Maybe there'd be like a function pointer and an object pointer. Done. We got the variable guys and the objects, like an instance of a class, and then we have the function guys. and then you just have a pointer of this, and you just assign him to now be a pointer of that, or a pointer of this. But it seems like you actually have to. Oh yeah, because doesn't it? Doesn't it have a type? Isn't it like a pointer to an int? Why exactly that's needed, I'm not sure. It seems like. I guess it's just something to appease the compiler. It's like a for declaration. It's like, hey, you are pointing to this thing, and you might not know what is there right now, but I'm telling you what it is. This guy's only able to point to a that, an integer point, an integer. Okay. The references part makes sense. Hey, is this reference a member of this guy? Cool. Const cast adds or removes const. So if we have something and then, I don't know, does that mean we're removing it from the actual thing, or does that just mean that we are casting it to no longer be const if it was const, or if it is const, casting it to be const? That way we can use it somewhere else. And if that something else requires it to be a constant, then it's happy. As opposed to just copying its value, which could maybe potentially change, maybe. A reinterpret cast reinterprets the bit level representation of one type as if it was another. Of one type as if it was another. Meaning we have like the value 3 in an integer. Is a reinterpret cast done at the is the whole point just to find out, and it's unsafe because if we go back and forth, then it might not be correct. So like if we have an integer that's 3, and I assign a float to be the reinterpret cast of whatever, the 3, well, hold on. If I do a reinterpret cast of that integer 3 to a float, well, isn't that the same as just static casting it to a float, kind of? Or is it, if it's just changing the bit level representation but not the data type, I could assign the same integer x is 3, and then I assign x to then be the reinterpret cast of itself, x, to a float. So it still gets an integer, but it gets the integer of the bit representation that a float would use to represent 3. So however a float represents 3, if it was a float, it would be 3. But we take that and leave it here as an integer. So we're saying basically, what would a float represent 3 as? And we can do a reinterpret and it will change the value, which is why it is not safe. We could reinterpret it back. And C style is a combination of these, but not dynamic. So between related types, const, and bit representation, it seems like these are the 3 generic regular guys. And then there's the cool guy, the dynamic cast for pointers and references and shit, object things that I don't know about right now. Input, the cast takes an expression, evaluates to a value or an object, so some sort of fucking thing, and it is returned as another type. The result of the conversion. The most commonly used casts are C style and static. Noted. Dynamic is later, after pointers and all kinds of craziness. Const cast and reinterpret cast generally aren't used because they're only good in rare cases and can be harmful. Safe for adding const, not safe for removing it. So I don't know if that actually changes the type of something or if the whole point is just to return it as a non-const value. That way, the future things can change it, or, well, I mean, it should be able to change it anyways. But okay. Avoid class cast and reinterpret cast. So the good guys are static cast and the C style cast. Oh, it's just straight up operator, really? Oh, so there was casting in C? Oh, I never got that far. We did pointers and arrays and shit, but not this. Interesting. I guess we were more in the phase of using fire, even though we don't fully understand it because it's useful, instead of now where I'm kind of learning what's useful about something and how does it work. Now let me use it, or kind of at the same time, where I don't go too far using something without understanding it yet. Besides, maybe why a standard string is expensive. I just know that it is. Operator parentheses, the name of the type to convert in it, and the value to the right. So it's a binary operator now? We put something in there and then... C++, this is a C style cast. Converted from C. So we could say something like int x is 3, int y is 4, float d is double x divided by y. Include iostream. Need standard character output. Conversion from double to float. Oh, oops. I did float, not double. Could I do the same thing? I could. Interesting. C style operator, boom. Okay. What happens if we did it with a string? Oh, I don't even have that yet. Oops. Just want to see if it works this way. Oh shit. You can cast it to a standard string like that. That's a C style. And that's a combination, it's saying? Some combination of this, this, or this. That's a C style cast of this integer to a double. Convert that to a double. The left operand of that is now a floating point. The right is converted now. Yes, due to the usual arithmetic conversion rules. Yes. C++ has an alternative form as a function style cast. Oh. I almost kind of like that more. I don't know what I like more. Because I like this because it's like static cast and then in the angled brackets we put in the type that we're converting to. So here we have it just in parentheses. But here it's like we just put a type and then as an argument we pass in the thing that's being converted. So I also like that. Because this is like the latter half of the static cast and this is the earlier half. This is where the type is in within some sort of operator. And this is where the operand, the value we're actually converting, is within some sort of operator. And it's actually the same operator. Maybe I like that more. What if we did... We need IOStream, need standard character output. We need string because need standard string. And here we need to output something and then end the line. What are we outputting? We're outputting a standard string hi. Oh, we're converting hi to be a standard string. I kind of like that. So we could do oh, that's kind of cool. I like it. I like the function style cast instead of the C style cast. That's cool. Oh, C style are avoided. And he was just saying that C style are the most common, bro. So, avoid, bro. Are you kidding? The most commonly used casts. Best practice, avoid them. Bro. Okay. Okay. It appears to be a single cast. It's actually... It can perform multiple. So it can be a combo. So it can be a static cast or interpret and a const. In the latter, we said you should avoid. And is the reason for avoiding it because it uses those? C-style doesn't make it clear, which makes it harder to understand, so you don't know exactly what's going on at the lowest level possible. And there's misuse where you think you're doing a simple cast and you end up casting some. Oh, okay, so like you didn't realize that there was a const cast in there, and now the value that you thought was const has now been changed, and now you didn't know because you were just doing a regular little cutesy C-style cast. Oh, so does this mean that we fully avoid them and don't even do function casts? Yep. Producing an error that isn't discovered until runtime. Oh, because it isn't done until... Isn't even done at compile time. Well, it said it does a static cast, const cast, and reinterpret cast, or it could. So maybe it doesn't get discovered till runtime because maybe it's not doing a static cast. Just a type name, parentheses, and then the operand. Yeah, they're harder to find because it's not as explicit. Static cast, this, blah, blah, blah. Type, this. Oh, true. Yeah, hard to search for. I mean, I guess it shouldn't be too hard if you do parentheses, something, this. But, well, yeah, but you have to explicitly include the ending parentheses because if you just did parentheses and then the type, Bro, that's every fucking function parameter you have. So anytime you have a standard string as a parameter or an int as a parameter, you're cooked. Unless you include the end part. But if you happen to be the guy who does the parameters without naming the fucking objects like a freak, at least in your for declarations, then it's going to show up with your for declarations too, even if you do it right. So, easy to spot and search for. They're explicit and they're clear. They're limited, so they do one thing, and they do a compilation error if you fuck them up. Avoid Z style cast. Okay, GG, we're only doing const cast. Woo! And then dynamic at some point. A C style tries to perform these. So it first tries to do a const cast. And so what, how is that working? Is that because we're assigning, if we're assigning a value to a const variable, then it will try and switch the non-const variable to be const. And then after, it will change the type, so it'll qualify it, and then do the type. Or if it can't do that for some reason, it'll change the type and then requalify it, and then it'll do a reinterpret cast for some reason, maybe depending on the use case, depending on the operands, maybe, for the thing that's being assigned or called. Or a reinterpret and then make it const. You can't do C++. Wait. Oh, we're talking about C++ cast, meaning like a static cast or these other ones. Can convert a derived object to a base class that is inaccessible because it was privately inherited. So derived meaning like a child object. So if we have a child object, we can actually convert it to a base class that we can't. Oh, okay. So there are different types of inheritance where you can only convert things if it's explicit. So like maybe there's a type of something that you can't make. You can't make a car. You can't make an object of car. You have to make a Chevrolet or a Corvette or a Hyundai or a Tesla or whatever. You can't just make a car. But you could do a C style, and that's because car is private, so you can't just convert it like that. But you could do a C style cast and just convert it straight up. As long as the compiler knows what's up, seems like it'd be okay. Static cast should be used to cast most values. By far the most used is static cast. Explicitly converting one type to another, like a character into an int, so we can output integer instead. Yeah, so if we wanted to print the ASCII code of a character, or if we were printing a uint8 and we wanted the actual integer version of it, not the character version of it, because the standard character output says, hey, what's the regular ass 1 byte version of an integer? Oh, that's a character, because the only one I know is a 4 byte one. So I'm going to print out the character version of your number. Which is not what we want. We want to print fucking 120, bro. Not A, or 123, not A. For the fucking caps version. Shut up. Or, oh, I guess it wouldn't be that high. 65 is the caps one. Never mind, I added a 26. Too high. Yeah, the higher ones are just weird stuff. Oh, wait. No, that would be Z, wouldn't it? Lowercase z. Yeah, so that is how we can avoid printing. That's how we can get the ASCII code of the character. We do static cast, we put in the type in angled brackets, and then the parentheses we put in the operand, which is the guy that we're trying to convert. Yes. Yeah, it looks like a function call to a function named that. Yeah, it makes sense. I still don't understand where the template stuff comes in. I don't know if it's literally a function. Excuse me, and it has some template stuff in there. Excuse me, or if it's a function and then somewhere inside it you put in the template stuff. Or if it's an object called static cast and you're calling it just like when you call a MRSA and twister, it has this operator identifier for the function, so you can call the function to get a number from it by just putting something in the parentheses, and that seeds it. And well, actually, no, you just call it and you don't even put anything in there. You initialize it with the other shit. So, but in that case, a MRSA and twister is definitely an object. So I'm not sure what a static cast is right now. Yes, that's exactly what it looks like. The expression whose value will be converted is provided as the argument. Static casting a value to another type returns a temporary object that has been direct initialized with the converted value. Yeah, it makes sense. We're basically saying, hey, create a temporary integer. Direct initialize them. I think that's what this is called. Instead of direct list. Like that. Direct initialization. Direct list initialization. So saying, hey, create this temporary double object and then direct initialize them. Which will mean that it won't get a narrowing oh yeah, it doesn't detect a narrowing conversion. Oh, that's probably why it's like that instead of list initialization. Because otherwise it would say, hey, narrowing conversion, and then it would complain again. Here's how we use it to solve the problem we introduced in the introduction to this lesson. Oh yeah, because we static cast. Yeah, it did us in the very, very beginning. Static cast them to whatever, some sort of floating point guy that we can do it. I happen to have, I assigned the thing and then printed it, but you could also do it this way too. Yeah, so you just need one of these guys to become a double, because the other one will get numerically converted to the floating point, because floating points are higher in the hierarchy than all integer types. Static cast to a double x returns a temporary double object that has been that has the value of the converted x, which in this case was 10. Now it gets 10.0. Temporary uses the left-hand operand of the floating point division. Yes. Two important properties. Check one thing. Oh, hell nah. Yeah, that's what I thought. Yeah, boy's done. Static cast is at compile time, yes. Yes. Yeah, if they aren't related, because in the static part it said convert a related type. A type to a related type. Not just any other type. If it's doing like a standard, like, yeah, exactly, I was about to say that. Some sort of fucking string shit to an integer. Man. But a string to a boolean is actually okay, because that's what we do in our asserts. We do the logical and then we include a C-style string. Ooh, we could. I wonder if that works. So if we include, I don't think I even need input and output. If I just include, well, I need string because we need standard string. assert. Need assert. And if we say in x is 4, and then we do assert x is greater than 3, and standard string. If I did standard string, well, hold on. What was I doing here? Oh. Yeah, if I just want to see if a standard string evaluates to a Boolean like that too. Because I know a C-style does. Because this evaluates to true right here. So if we put in x must be greater than 3, then it would be fine. And it would say that part's true. That part's always true. So this assert is true whenever the condition's true, or the x is greater than 3. Oh, and then actually in this case, we're going to say is greater than 4. And standard string, we're going to do a little regular ass conversion guy. Actually, in this case, I don't want to do that. Let's just do a static cast to a standard string. X must be greater than 4. And then what is the issue here? Yes. Does not work. But if we do that and that, then we're cool. So a standard string does not evaluate to a Boolean true or false. Interesante a mí. So we could say like, well, yeah. Yeah, that's it. I already figured it out. Cool. So C-style can't be converted to an int, but it can be converted to a bool. Yeah, and static cast does the conversion at compile time, so we get compile time errors. Yep. C-style string can't be converted to an integer, so we get an error when we're trying to direct list initialize x with that integer result. It's less powerful than C-style because it prevents dangerous shit, such as those that require reinterpretation or discarding const. Yeah, because the reinterpret cast or the const cast. Because they could remove const and we don't want to remove const, or maybe well, I mean, it could make something unchangeable that you wanted to be changeable, but that's probably not as likely, or not as problemsome. Not as bad. I don't know. And then reinterpretation changes the value. So if we had x is 3, and then we did, hey, x is reinterpret to a float x, we'll say, hey, you get the value that a float would represent 3, which is going to change what your value is. Because you're not getting the float shit, you're getting the binary that the float would have. You're like copying out of his book. Doesn't mean you're going to get, well, the answer's not going to be right, if that's what you're looking for. So it could be dangerous. Yes, ideally do static cast. A value from one type to another. Okie doker. Static cast uses direct initialization. Any explicit constructors will be considered when initializing the temporary object. Yeah, I don't know about that. I don't know anything about explicit. Is implicit a keyword then? Explicit? Implicit? No, implicit doesn't seem to be. To make narrowing conversions explicit. Yep, compiler will issue warnings when we're using direct list initialization for type mismatches or other things that are narrowing conversion, where the target type cannot hold all values of the initial type. Could make it const expression, and then the compiler will check to see if this specific value fits. If you don't have const expression, or at least const, then it will not check and it will just give you the error instead. Excuse me. Yeah, so if we're doing this, we're saying, hey, I is 48. Well, we know that a 1 byte integer, a character, cannot hold all possible values of an integer. Yeah, and int 2 or 4 bytes, a character, could be unsafe. Yeah, we don't know if it's going to overflow or not, so it could be safe, might not be safe. Make it const expression, could be cool. And if we know that the value is specifically safe, because we could totally get overflow if we do 128 here, we'd be fucked. But we could just say static cast and say, hey, get that integer value, motherfucker. And then if we print it, again, it's going to be a letter, a character, not a number. Yep. From an int to a character, so that a character is assigned so a character is assigned to ch. So it's saying, hey, 48, become a character. Now, character value, be assigned direct list initialization to ch. Yes, we accept responsibility. Overflow, if it happens, cool. Yes, because the direct list initialization will see, hey, character value being sent to a character. We're golden. Yep. So we have an int, and we're assigning it the value of a double. So we get a narrowing conversion because we know that integers can't hold decimal values. We could do a static cast of 2.5, which gives it 2. Which then means we're taking 100 divided by 2, we get 50. Instead of 40. Static cast for class types later. Oh, soon. Soon. We get class stuff soon. Temporary classes are at 14. So surely classes are like 13 or something. Let's see what's next. I'm curious. No harm. Templates. Holy shit. Const expression functions. References in pointers. Enums and structs. Class templates. Classes. Oh my god. These next chapters are about to hit hard. About to be a lot of learning. So much. And it'll probably be just like standard string. Where it's like, hey, use it. This is a little about what it is, but you're on your own, buddy. Which is perfect. I just want the information in my brain. That's all. Okay. Casting versus initializing a temporary object. X that we have x, we need to convert them to an int. So we could do static cast of an x. Or we could just say int and assign it x and then give it something. So x could be like a character, and then we type, well, I guess it's type conversion. It feels like numeric promotion, but maybe it is type conversion technically. I think it is actually numeric promotion. Temporary int, direct initialized with x, versus that is a temporary int object, direct list initialized with x. Gotcha. So you can do two ways. It just depends on whether we have a narrowing or not. And we should avoid int this, because if we have this variable already in here, then we are doing a C-style cast. This is a temporary direct list guy, but it could also be fucking up with the const or be reinterpreting. So for temporary stuff, probably better to do static instead of doing the regular little unnamed stuff like we're doing for for a uniform int distribution, and then the braces to initialize it, and then the parentheses to call the Mersenne twister from it with it. 3 notable differences between the static cast and the direct list initialized temporary. That is list initialization, which disallows narrowing. Yes. Yeah, so if we're doing static cast to explicitly okay narrowing, that would not allow it. Yes. But when using it as a cast, we're supposed to know what the fuck we're doing. Yes, makes sense. So if we're trying to use it to make an integer be printed as a number instead of, or a character be printed as a number, or an int 8 be printed as a number and not a character, then we don't want to say character int 8. Well, actually, if we did character int 8, I guess that could still technically work, and it wouldn't overflow either. Yeah, if we're trying to do it where we're actually changing the amount of memory and would be narrowing, then alright. Platform specific. So we have int x, int y, and we say, hey, double x. So we have y, and then we have x. So, depending on the platform, would a platform actually, by default, make an int an 8-byte guy? Because if it's an 8-byte guy, then he might be larger or equal to, well, then he might be the same or greater memory compared to a double, which means that he can hold higher and lower values, higher positive and lower negative values, which means that a conversion of an int64 to a double is actually narrowing. So if we do static cast, then it's cool. But in this case, we could still get a narrowing conversion here. So yes, this is just showing that, hey, by the way, this is direct list initialization, not list initialization. Or sorry, well, same. This is direct list initialization, not direct initialization. On 32-bit, this is cool because a double can hold all the 32-bit stuff, but on 64, a 64-bit int is the default. Yes, makes sense. Static cast makes it more clear compared to a C-style cast. Makes sense. Yes, it's more verbose, cool, but it's showing you explicitly, hey, I can search for when we're doing a static cast from that damage to an integer, because I don't want all these decimals in my damage, I just want fucking integers. So we would normally get a narrowing if we're converting the float to the double in this case. But I'm doing a static cast, so we're good. I might start alternating. Like, well, I think what I do is I always include the last like 3 chapters in the learning section of the day, but then I rotate with which part of the earlier stuff. So if we're doing chapter 10 now, then I'll include 10, 9, and 8. And then in this case, today, I might do 1, 2, and 3. But tomorrow, I might do 4, 5, 6, 8, 9, 10. And then the next day, we do 8, 9, 10, 7, 6, 5. And then the next day we do 1, 2, 3, 8, 9, 10. And then 4, 5, 6, 8, 9, 10. And then 6, 7, 8. Or 5, 6, 7, 8, 9, 10. And eventually we get to 14. And then we say 13, 14, or 12, 13, 14. And then 1, 2, 3. 2, 3, 4. Boom, boom, boom. Or maybe it's 1, 2, 3, 4. Boom. Because those will just be easy enough to answer. So, because I want to be testing myself on everything so that it's in the fucking brain zone. If I get tested on stuff every day, it's just going to be locked in. Just like, what is it? Patience, kindness, honesty, something, don't play around with electricity. I had my professor, Mr. O, in middle school, and we repeated this shit every single morning. And that's actually different. Well, no, because in tests, we had to remember the, I think, 10 or 11 virtues that we had. Something like that. Patience, kindness, honesty, don't play around with electricity, integrity, probably. I don't remember the rest. Mr. O, virtues, patience, kindness, honesty. Bro. Here it is! Holy shit! I don't want to click this. Kindness, honesty, self-control, courage, love, respect, responsibility. Holy shit, dude. I remember this. Oh, wait. Damn, I thought it was going to show the rest. Oh, yeah, here we go. Yeah. Don't clown around with electricity. Frugality, integrity, generosity, understanding. Holy shit. I remember those 16 of them. Fuck. I only remembered 5. Damn. But I haven't thought about that in like 14 years. So, being tested on that, every test is for bonus points. Helpful. Okay, yes, it's more verbose, it's easier to find. Okay, cool. So it's basically, static cast allows narrowing conversions because we're explicitly using it on purpose. We should be aware of potential narrowing conversions. Cool. And we should be allowed to use them. If we do a C style, it won't allow us to use them. It's also more explicit. We can see and we have to type more shit to make it happen. Cool. Just like if I want to aim over there, I have to move my arm more. So I prefer less sensitivity. I prefer low sensitivity. Direct list initialization of a temporary only allows single word type names. Oh, like a constant thing, or oh, you can't do an unsigned int. You could do uint. Direct list initialization of a temporary. So we can't do unsigned int. Wait, really? Oh, but yeah, because MRSA and Twister, MT19937, uniform underscore int underscore distribution is one word as well. I guess that's true. A weird syntax quirk. There's several places where only single word type names are allowed. Simple type specifiers. But you could probably get to them another way, like a uint 16t instead of unsigned int, or uint 32t. Yeah, so we could try doing. We need input and output. Oops. Need standard character output. We don't actually need the input. Standard character output. Unsigned int. What we could do, well, unsigned int 5. He's a liar. Are you kidding? You liar. But what if it's... Oops. And x is 3. And then now what if we say unsigned int x? Oh wait, what am I doing? I'm not doing... Oh, compiler error. Well, that's because it's the narrowing. But in this case, it's still letting us do the type. It feels like it's not totally true. So like if we did float x 3.0f, and then this was long double. Wait, hold on. Yeah, long double x. Oh, it's allowed. Are you tripping? Okay, I don't know why it's saying that. Alright, it seems like that's maybe not true, at least in this IDE. Where the direct, well, it says direct list initialization. We're doing direct list initialization of a long double 2x. And in this case, he's saying, like, so what happens if I do this? It still works, bucko. We are printing this guy as an unsigned int when we get 97. Yeah. Which you could do a uint. Yeah, exactly. Oh, I forget uint is actually a thing. I always remember that it's always, or I always keep thinking of like uint 32 or int 32 or whatever. You could just do uint. Makes sense. Yeah, maybe this is like a C++20 fix or something else that he's just not considering. Yeah, we don't have to do the simple type specifier in this case. Excuse me. Unsigned character using uint. Using uint is unsigned int. Oh, I've never even seen that before. I guess instead of including C standard int, you're doing it like that? Oh, a quiz. Rare. I don't even remember the last one of these I've gotten. Holy shit. They always make me nervous but excited. Yeah, why go through the trouble of including uint to use unsigned int in the short version just so that we can use a C style cast, all just to not fucking understand what's going on. Yeah, let me cut my shit off just to not understand the world. Let's go. Alright. For all these reasons, we prefer static cast over direct list initialization of a temporary. Yeah, makes sense. This fucking allows narrowing, which is probably what we want, at least in these cases. Otherwise, we would just fucking do it. Otherwise, we would just have them implicit. It's explicit, so we can see what the fuck's going on. It's more verbose, so it requires more typing so that we know that what's going on. And the third one's a moot point. This isn't true. It requires single word type names, at least not in Visual Studio 2022. First static cast over initializing a temporary for a conversion. Basically, just avoid C-style explicit conversion. Type conversion. What is the difference between implicit and explicit type conversion? Implicit type conversion is whenever the compiler is seeing that there is an input type, and that input type differs from the type that is receiving it. So we're passing an integer as an argument into a function that has a parameter that is an unsigned int, not an int. There's the start and the finish. There's the input and there's the real input and the expected input. It's when the real input and expected input differ, and the compiler tries to convert from the real input to the expected input. Whereas in explicit type conversion, we are explicitly telling the compiler that, hey, this is the conversion that we are wanting, and it is okay. Allow narrowing, or allow, whatever. Do it this way. We're explicitly saying the exact way that we are trying to convert it. And that is done without any target type needed. So there's an input, and all we're doing is we're converting it. There's no, the static cast happens, or the explicit cast happens, or the explicit type conversion happens before we even assign it to anything. So it's like converting in advance explicitly. So the implicit is the compiler filling in the pieces. Hey, here's an int. An unsigned int is trying to receive it. Therefore, implicitly convert him. That way he can go become an unsigned int. And now we're going to have a narrowing conversion. Fuck me. An explicit is saying, hey, there's an int, and I am just explicitly converting him to an unsigned int. Nobody gives a fuck about the rest. It just so happens that the result of this that is now converted explicitly can now be used okay, and there's no mismatch between itself and the target. Yep. Implicit is the compiler filling in the gaps automatically, and it's a difference in expectation and reality. Whereas the explicit is the programmer uses it to convert. So there's no expected type, it's just explicitly converting. There's no expected thing. Oftentimes we use a thing that gets the value, but we don't have to. We could just convert it and then leave it as an expression statement. Type def? Oh shit. Are we about to learn struct or something? C++ using is a keyword that creates an alias for an existing data type. What the fuck? And using is a keyword that can also do this. Instead of just using namespace, we can also say using, and then it's not namespace, it's some sort of string that is assigned whatever it is the alias of. I need some music. Oh, this song is great. This could be good too. Oh, I'll listen to that in a minute. This is already solid. I kind of want to do a couple push-ups really fast. It's fine, it's relevant enough. I'll do 21, 2, 3, 4, 5, 6, 7, 8, 9. Once defined, a type alias can be used anywhere a type is needed? Do we have to forward declare to something, or is it the whole program? Are you sure? What's happening here? Or is it file scope? Like a preprocessor directive. Seems like it's within scope. Yeah, probably. Okie doke, so we'll say. Man, this girl is freaking pretty, dude. Her voice is amazing. I like all these colors in the background. Makes her seem cooler than she probably is, but damn, these blue eyes, dude, holy. There it is. Yep, thing unidentified. Yes. Cool. So it is within scope as expected. Within scope, but duh. It's a fucking statement. It's not a preprocessor directive, which doesn't need a semicolon because it's not a statement. Can I do it here? Oh, cool. But that's file scope. You'd have to have within a block or within a big function, if not defined, using this is this, and then and then an end if, or actually I don't know how to make it restricted because I think it's just in scope already. Or maybe you can do undefined. Can you do that? Undefined? Yeah, you can. So we could do define thing as bool, and then use thing for bool or as bool alias, and then undefined thing. Boom. I keep doing Control Shift S, or I keep doing Control Shift A instead of S, or instead of Control A, because I'm used to doing Control Shift S to save all files every time. Did it already loop? Holy shit. Yeah, so we could say using. Alright. Prince 3.4. God, the voice is pure. It's nice. It's just clean and clear. I love that. Yep. Yes. I don't know why we would want this. I really don't. Can also be templated, meaning, oh, like we have the alias, and then we can put in a template that, so we convert it to thing, and the compiler converts the thing to bool, or just replaces it with a bool. Not a lot of consistency for type aliases. I don't know why we would want a type alias so far. Unless we're talking about new shit that's a struct. But I don't think we're doing this because I think we have to do struct type def or something like that. I remember we used type def in C, but I don't really remember. End in a T. How is it looping so fast? It's a 3-minute song. It's already happened twice. God, the voice is addicting, dude. Yeah, so thing T. Standard library. Yeah. Size T, uint T, fucking int32T. Inherited from C. It used to be the most popular when defining your own. But now, phone out. POSIX for globally scope. Yeah, see, it might have naming conflicts. Gotcha. I don't know what a POSIX is. I guess it's an operating system. So if you did something that was already defined with underscore T there, well, you're cooked. Type aliases. So there's underscore T, there's underscore type, and then there's none. Oh, capital but no suffix, just like a namespace. Okay. So we could do underscore string size underscore type. Yeah, that's fucking retarded. Some standard library, so like string underscore type. Oh, like a result type, or size type. Oh, what do you mean? Like the type of a size of a string? So what is it? Just an unsigned int? Oh, result type is probably an alias for something. Well, no, because that's string. Oh, I guess we could say using, and then there's. What are we calling here, though? That's the question. Like, there's no operator here. I mean, there's just a scope resolution operator. And if we just say size type, is it a string that. Alright, well, that's it for now. Oh, it's loud. 30-minute break. Oh, wait, no, I changed the live time. Fuck. Oh my god. Stop. Fuck, I accidentally went 1 minute past. Stop. It's 9. We go again at 9:30. Okie doke. Alright, and having the light on is definitely the play. Dark outside sucks for programming. It's ass.